Welcome to Spring LIB.
Hello everyone, today we're doing chapter 18, problem 80, and this problem asks us to devise a stepwise mechanism for the following reaction, and it gives us a little hint. It says that the reaction does not take place by a direct electrophilic aromatic substitution at carbon 2, which is this carbon right here, and it says the reaction begins with the addition of electrophile at carbon 3. So let's start off with identifying potential nucleophiles and electrophiles. So right away, we see that this oxygen can attack this boron group here to generate some sort of electrophilic species. And now boron gained 2 electrons, so it's going to have a minus charge, and oxygen lost 2 electrons, so it's going to have a plus charge. But now we'll use the hint, and we'll move around these 2 electrons on the nitrogen to make a new pi bond here, and a carbon ion on carbon 3. Now this nitrogen is going to have positive charge. There's going to be a negatively charged carbanion here. So now what can happen is that this carbanion can now nucleophilically attack this carbon atom, making a bond. You make a bond, you break a bond, and that's going to go to this oxygen atom here. So then what you're going to be left with is something very interesting. You're going to have a cyclopentane now off of one carbon atom. With BF3OH still has a minus charge. But see, now here's the interesting part. So here we have a positively charged nitrogen and we have a cyclopentane. Well, we know that cyclohexanes are more stable than cyclopentanes, and we know that positively charged nitrogen is not that favorable either. So what's going to happen is something very interesting, is that these 2 electrons on the sigma bond will break such that they will bond now on carbon 2, making a bond. You make a bond, you break a bond, so then that's going to bring those 2 electrons onto your nitrogen nucleus. Oh. And now what we're left with is now a carbocation intermediate on this carbon with a proton adjacent to it, and we need to reform our boron trifluoride catalyst. So what's going to happen is that those 2 electrons here are going to go and pick up this proton, making a bond. When you make a bond, you break a bond, the sigma bond will reform our pyrrole that we've had. And now we reformed our catalyst, and we formed water as well in the reaction.